Hello everyone, I am Ajay. Welcome to Online Learning's infyTQ training. Today we are going to solve data structures and algorithm based MCQs. Coming to the first question, which of the following statements are true with respect to array data structure? Okay, let's take array data structures. Okay, the first option is inserting an element at the end requires shifting of elements of an array. Okay, let's take the example 1, 2, 3. Suppose this is the array, and if you want to add another element like 4, if you are using Python, like we can use append. If you are using Java array list, then we can use add function. So in those functions and all, there is no shifting operation being taken place and internally. So this option is wrong. If you add at the end, there is no shifting operation will happen to the array data structure. Coming to the second statement, elements of an array can be accessed randomly as well as sequentially. Yes, it's true. We can access randomly and can be accessed sequentially from the array using the index. Like if the variable is array, and we can just pass array of index, and that particular index data will be returned. So this statement is true. Inserting an element at beginning requires shifting of elements of an array. Yeah, it's true, because if you take an example like this is 1 2 3, and if you add one more element like 6 at the beginning, then the base address of the array will be changing. So to maintain that, the base address will be shifted to 6 and the other address will be shifted to the right side. So the one address will be shifted to 2, two address will be shifted to 3 to a new address. So this way shifting will happen. So this is also correct. Same way even for the deleting as well, because if we delete this one, so it means we are deleting the base address. So we want to restrain the base address. So 1 will be moved to the 6th location, 2 will move to the 1st location. So it will again come back to this. So shifting operation will be happening in that if we do deletion at the beginning. So this is also correct option. So for the first question, last three options are the correct statements. Let's move to the next question. Yeah. Which of the following statements are false regarding array data structures? So we need to select the ones which are false. Okay, which are false. Okay. Deleting an element from the beginning of an array requires shifting of elements. Deleting an element of the beginning of an array requires shifting of elements. Yeah, it requires. This is true, but we want the false statement, so we cannot choose this. So this is neglected. Inserting an element at the end of an array does not require shifting of elements. Inserting an element at the end of an array doesn't require shifting of elements. Yeah, this is also true, but we want false statement, so we should not consider this option. Elements of array cannot be accessed randomly. Cannot. It can be accessed randomly. So the statement is false. So we need to select this because we want the false statement. And elements of an array can be accessed sequentially, but here it mentioned as cannot. So this is also false. You should select this option. For the second question, option 3rd and 4th are the correct answers. Let's move to the next question. Third question, consider service hotline. Sometimes when a call comes in and there are not enough operations to handle the call, it is placed on hold. And the next call comes in, it is also placed on hold, and then this continues till the operation becomes available. When the operation becomes available, the first call that was put on hold gets assigned to him or her. Which of the below data structures is optimal to return the call on hold? So if we take our example also, if we want to complain to the customer care of any of the company, then we just call to the toll-free number. Then we generally find that there's an auto-generated message that your call position is at 2. You need to wait for the two more positions, 2 more persons call need to be attended before your call need to be addressed. So such kind of auto-generated address need to be handled in the customer service sector. So such kind of handles, basically they follow is a kind of first come first serve approach, which means if a customer comes first, this customer need to be approached, this customer complaint need to be addressed first, then another next person, and the next. So such queue will be followed, and the first come first serve approach will be maintained here. So for this scenario, the best data structures will be queue of course, because queue follows first come first serve, and also it maintains the complete order. And using queue, we can also tell that a person is second in the position and he need to wait for the call because 2 more persons are ahead of him. So the option is Q for the third question. Coming to the fourth question, consider a treasure hunt game in which you are Okay, you are handed a clue that leads to another clue and so on until you find the treasure. The first clue links or points to the location of the next clue. The second clue links to the location of the third, and so on. So basically, you are at a place and you found a clue and you got a next location. Again, you found a clue. Again, you go to next location, and next location, and so on until the treasure. Yes, sir. So for this, what is the best data structure that can be used to solve optimally? So if you can observe, this is looking like a linked list. Because if you take a linked list which has a data and a node, that is address of the next node. Same way, next this will contain the address of this one. So it's basically like this scenario. This is the data and this will clue will contain the address of next clue. This will contain the clue of next address of next clue, so on. So if you are using a linked list, then we can easily determine, we can easily plan this game for using the linked list. So the correct answer for the fourth question is linked list. Coming to the fifth question, let's zoom this in. Okay. Given the following linked list 12, 34, 26, 67, 98, what will the state of the linked list when the following Python function is invoked by passing the head node of the above linked list and 3? Okay, head is passed and n is equal to 3 is being passed. Okay. Now let's take the linked list 12, 34, 26, 67, 98. Okay, this is the linked list and n equal to 3 is passed. Temp equal to head, so we are declared an variable temp. So this is the temp. Now head, if head equal to none, no, it's not true, so it will go to the else part. I equal to none and I not equal to n. N is here, it's 3. So until I becomes 3, this loop will execute. So next in the loop, temp equal temp dot next. Okay, temp will move to temp dot next. The temp is here at 34. And I equal to I plus 1, previously it was 1, so it become 2 now. 2 not equal to 3, again temp will move to the next one. Okay. Yeah, so here is the temp here. Now I became 3 here, 3 not equal to 3, it's false, so loop will break, so temp is presently at 26. Now another variable temp1 which store the value of head, that is head dot data is 12, so temp1 will store 12 data. Head dot data equal temp dot data means head dot data is been replaced with temp dot data. So 12 will be replaced with 26 here. And temp dot data equal temp1. That means temp dot data, that is 26, is equal to temp1, that is 12. So 26 will be modified to 12. Our final linked list we have is 26, 34, 12, 67 and 98. So by considering all the option, 12, no, this is wrong. Okay, 26, 34, 12, 67, 98. Yeah, so option B is the correct answer for the fifth question. Let's move to the next question. Okay, let's zoom out a bit. Yeah, what is the state of linked list when the following Python function invoked by passing the head of it? So this is a linked list. Okay, yeah, let's load this linked list again. 12, 121, 112, 111 and 222. Okay, again temp equal to head. Okay, so this is the temp. If head equal to none, no, it's not, so else part. When temp dot next equal to null, so not null means at this condition, none or null, anything. Yeah, none or null. So at this condition, this while loop will fail until the while loop will continue. Temp dot data plus equal to temp dot next dot data. Those who don't know what this does is, let's take a basic, like a plus is equal to c. This can be represented as a equal to a plus c. To represent this in a shorthand, we use a plus equal to c, which means a equal to a plus v. So same way, temp dot data plus equal to temp dot next dot data means temp dot data equal to temp dot data plus temp dot next dot data. Okay, so temp dot data is equal to temp dot data plus temp dot next dot data, which means 12 plus 121, which is basically like 133. Yeah, 12 plus 121 is 133. Now in the next iteration, temp will move from here to this position, the next position, that is here, temp. Now again this two will get summed up, so 233 will be the data will be changed here. Again temp will be moved here. This is the temp. 120 plus 111, so that is 223 here. Again temp will be moved to the next one, so this is the temp. 111 plus 222 is 333. Then temp will not move to the this one, because temp will move to this one at this point, that is temp equal to temp dot next. So after coming to here temp, it will check the while condition whether temp dot next not equal to null or not, but temp dot next is null, so w will break here. The linked list which we got after updating is 133, 233, 223, 333 and 222. So the correct option is 133, 223, no, 133, 1, no, 132, 233, 233. Yes, so option C is the correct answer for the sixth question. Let's move to the last question. Given the following stack, top to bottom, okay, let's draw the stack first. Okay, it's top to bottom, right? Okay, 7, 12, 1, 5, 4, 2. Yeah, this is a stack and it's named as stack 1. Okay, if stack is empty, no, it's not empty, then else part s1 equal to stack. In Python we can use our default method stack to create an empty stack. So this is s1. So s1 is ready. While not stack 1 is empty, so the while loop will run until this complete stack is being emptied out. Now s1 dot push, so we need to push something into it that is being popped from the stack 1. So if we pop 7 from this will be pushed here, and again stack 1 dot pop, 12 will be popped, 12 will be pushed here. Now s1 dot push equal to s1 dot pop into s1 dot pop, means we need to pop this to multiply it and again push the resultant into this stack. So let's pop this, then first will come 12, then 7, the 12 7 is 84, it will be coming. Then we need to change the stack to, second, yeah, so we need to pop this out, then into push the resultant, that is 84. Yeah, this iteration is done. In the next iteration 1 will be popped, pushed here, and again 5 will be popped, pushed here. This is done, and here in these conditions this both will be popped again, so it will come as 5 into 1, that is 5, and the resultant will be pushed into the s1 again. So resultant to the s1, that is 5. This is done. Again in the next iteration 4 and 2 will be popped, 4 and 2, if both 2 are popped again, then 2 into 4, that is 8. So the resultant will be stored after these 2 are getting popped. So 8, it is the correct. So from top to bottom 8, 5, 84 is a sequence from top to bottom of s1. So let's check the options. 85 to 84, that's option C. So option C is the correct answer for the 7th question. All the best. Thank you.